Welcome to everyone in the course Introduction to Embedded Systems. I am Professor Bijay Kumar Upadhyay from Electronics and Communication Engineering of Tripura Institute of Technology. In today's lecture, I am going to introduce this course to the students and also give you an overview about the course, the content and the application area of this course. So let's start our discussion. The course includes the name of the course, Fundamental of Embedded System. It has a specific code like OE. OE stands for Open Elective. It's a subject offered from Electronics Department and the actual numeric code is 803. It is a 3 credit course, so there will be 3 lectures per week, and it is, as I told, open elective subjects. So this is the subject offered to the students of other branches except electronics and communication engineering. Now, dear students, why should we study the embedded system subject? What is there in embedded system? Embedded systems are everywhere around us. Wherever we see, we will find embedded systems are in and around us. Embedded systems are found inside machines, devices, and infrastructure. It enables intelligence, automation, and control. We can control a different application. We can use them in automation, and we can embed intelligence also among them. So these embedded systems are backbone of modern technologies such as Internet of Things. You might have heard about robotics, smart systems, etc. So from the very fundamental definition, an embedded system is defined as a dedicated computing system designed for a function. So it has a specific function to serve, unlike the general purpose computers. uh, it works as a part of a larger system, and it is normally optimized for performance, reliability, low power consumption, real time operation. When compared with general purpose computer, embedded systems are found to be task specific. They are very much confined to their application area, and they have got limited resources, means resources will be used to their optimized level. And in most of the time, these embedded systems are real-time systems. We will explore this in much detail in the course progression. If we compare general purpose computer, so which will be having multitasking, uh, and these are user driven, and this requires high memory and processing power in general purpose computers. Normally the embedded systems are having a variety type of applications, and some of the applications, like in consumer electronics, we come across mobile phone, TV, washing machine, microwave oven, etc, etc. Then in automobile and electric vehicles we find embedded system applications. Medical devices and healthcare system, lot of embedded systems are being used. Industrial automation and robotics, full of embedded systems are being used for industrial automation. There the role of robotics is enormous. Presently, smart agriculture, which involves an environmental monitoring embedded system uh, to great extent. So this course has got very importance across the engineering branches. In mechanical, they are used in automation, robotics, CNC machines, etc. In civil engineering, they are used for making the smart buildings and monitoring the systems. In electrical engineering division, control system, power electronics, etc. In IT, computer science domain, they are used in embedded software, IoT platform. So it is basically an interdisciplinary subject, and it will be very interesting to learn about the fundamental of this course in this semester. The course outcome as per the syllabus are like this. There are four course outcomes, CO1 to CO4. So this course will help the students to learn, and finally the students will be able to illustrate the concept of embedded system, outline the operation of ARM7. ARM7 is a very advanced type of microcontroller architecture. So we will have the opportunity to learn about my ARM7, and these sort of processors are being used, microcontrollers are being used in many modern applications. Third one, explain the available architecture of embedded system, what are its different components, how things are arranged, what are the architectural design of embedded system. And to run all these things, we need software, system software, which in case of embedded system is called real-time operating system. Though this course is an introductory course, so we will be basically learning about the basics of RTOS, that is real-time operating system, which are used in embedded system. About the course content, this course is divided into 4 modules. Module 1, where we find some introductory embedded system concepts like definition, characteristics, then different classifications of embedded system. We'll have a comparison, detailed comparison on embedded and general purpose computing systems, then different features and application areas, and also real life examples. In module 2, we will be mostly exploring the architecture of embedded systems. So there are different architectures like what will be the processor cores, whether the CISC type of processor core will be used, whether RISC type of processor core will be used, what is the architecture of ARM processor, what is the architecture of DSP processors, what is called a system on chip, what is their architecture, and certain memory organizations we will explore in module 2. Module 3 basically deals with the ARM7, which is, as I have been already told, that it is basically a very popular architecture, ARM7 advanced RISC machine. So there we will explore the basic architecture of ARM7, its initial instruction sets, then different addressing modes and simple assembly language programs. And in the architecture, it has been built around pipelining, interrupt and exceptions, which helps in making the processor faster compared to its other competitors. And in module 4, basically we will be able to learn about the real-time operating system with example, different types of real-time systems, and a comparison between the real-time OS and general purpose OS, why RTOS is required in embedded system, and the RTOS kernel and its function. About that we will be able to learn in module 4. So finally, the assessment and engagement process is like this. The course includes class test, midterm examination, assignment and quiz to ensure that the continuous learning and concept reinforcement rather than rote memorization. This is as per the recommendation of Tripura University. And the takeaway message is like this: if you are curious about how machines think, react and control the physical world, this course will give you the fundamental understanding needed to explore that exciting domain. So, my dear students, let's explore the course on fundamental of embedded systems, and I wish you happy learning to all of you.